Good morning. Thank you. It's a great privilege to be here. I'm going to tell you a little bit about work in Australia that at the moment, both in genetic improvement for Hereford cattle and cattle generally, and then focus on some research and development work which has potential for both Australia and the international Hereford populations. The first, just give you a quick snapshot of Australia, the beef industry first of all. We have approximately 12 million breeding females in the country, roughly divided equally between the southern half of the continent, which is temperate, and the northern, which is tropical or subtropical. We have no native cattle breeds at all, so Hereford and everything else came to Australia from other countries. We have a system of funding for research and development, which is usually a mixture of levies collected from the farmer, matched by the federal or state governments. And there's a number of different models for that in some cases lead to long-term funding programs that are very useful for genetics research. The total investment that's being made in Australia in genetic improvement for beef cattle each year is something like $8 million US or $10 million Australian, and that's a mixture of research and development funds coming from the government and industry and the cost of recording that the breeders themselves make. Our markets are very, very heavily overseas. 2/3 of our production in Australia is exported to quite a wide range of countries, but particularly Asia and the United States. And just to give you some comparison, currently the cattle price to the producer in Australia is about just under $5 US per kilo carcass weight. I'm sure most of you know something about Australia, but probably the most important thing is it's a very large, dry place. That's a picture showing the red bits are places where you can't really run cattle because there's not enough water, and the green bits around the outside is where cattle production is feasible. So a lot of Australia is really not suitable for cattle production. There are lots of different animals. I'm sure people know what kangaroos look like, but we also have sharks and people who go to the beach, and there's lots and lots of sheep in Australia as well as cattle. But it's a very large place with lots of animals and not really very many people. Just to focus now on genetic evaluation and genetic improvement, BreedPlan is the system that we use in Australia for all the beef cattle breeds. It's a system that was developed in Australia nearly 40 years ago, I guess it started, and focused on the use of BLUP technology. And since the mid-1980s, all the major breeds have been doing national evaluations that allow a cross-herd genetic evaluation using multiple trait animal model. The sorts of breeds that we have that are active in the country, you can see there I've grouped them into the heading of what we call the British breeds, which are mainly used in the southern part of Australia, the temperate part. That's Angus, Hereford, Shorthorn, Murray Grey and others. And the new animals that are coming into evaluation each year in those breeds is about 100,000 new animals to be evaluated. We've got a number of European breeds, Charolais, Limousin, Simmental. Between them they are enrolling something like 15,000 new animals a year. And then for the northern part of the country, the tropically adapted breeds, Brahman, Santa Gertrudis, Troutmaster and so on, about 20,000 new animals. And more recently, Wagyu has become quite an important part of the beef industry, growing fairly rapidly, currently doing about 5,000 new animals a year. But so Hereford are considered to be one of our British breeds, and I'll tell you more about Hereford shortly. The main features of BreedPlan, and some of you will know some of this, but it's built around breed-specific genetic parameters. So the Hereford evaluation is built on Hereford heritabilities, genetic correlations and so forth. The analysis can incorporate F1 animals, so if they're crossbred Hereford animals, that could be included in the analysis. We import breeding values on overseas sires to incorporate them into the Australian analysis. In the case of tropical composite breeds, the model adjusts for breed effect and heterosis. That's not relevant to Hereford. All the main breeds conduct their analyses at least monthly, so all the information is updated approximately monthly for Hereford. And in the case of Hereford and several other breeds, we're routinely incorporating data from New Zealand and Southern Africa in the routine evaluations. We're right in the middle of the process now of moving to single-step multi-trait genomic evaluation. I know Dorian's going to be talking a little bit more about this as well. We're testing that on a number of breeds right now, and we anticipate implementing that during the course of this year. Breed plan covers a very broad range of traits that are relevant to cattle production. I'm not going to go through them one by one, but basically you can think of them as growth traits, including, as I've noted there, the milk effect, the maternal effect on growth, but it's basically birth weight all the way through to adult cow weight. The fertility traits, there's a number there. They're expressed generally in days to calving, which is a measure of branding rate. A growing number of carcass traits are being incorporated. There's quite a bit of R&D going on to develop an extended list of new carcass traits that some breeds will be accessing. And then there's a range of other traits I've included there: net feed intake, which is a measure of feed efficiency, docility, and there's some more as well. But there's a comprehensive picture of the animal's genetics for all the different traits that influence income and cost across those trait groups. The other feature of the standard feature of the genetic evaluation is selection indexes, which are developed in Australia for breed plan using a tool called Breed Object, which is built around derivation of the economic values for each production system, each market that's relevant for that breed. All the main breeds using breed plan typically have 2 to 4 standard dollar indexes, and they will describe different ways in which that particular type of animal is used for production and for the market. We're currently upgrading that software to add some new features that include considerably more modelling of the cost of feed, so that the total lifetime cost of feed in the system. Methane can be costed into the index. Cow condition score, which is being included partly as a measure of risk of animals basically falling below an acceptable level of condition and requiring intervention of some form or another. And also the ability is being incorporated to focus in on particular parts of the value chain. So if people want to just look at the cow-calf sector or the feedlot sector or retailing, that's also possible in the new version of Breed Object. Just to stress the point, Breed Object is built around the whole commercial production system, all the way from the cow herd through to slaughter. It addresses the genetics of the calf as well as the genetics of the cow. And so you can see a range of the traits that are valued there that can be incorporated into the breeding objective and hence into the selection index. And as I said, we can concentrate on different sectors of the value chain: cow-calf or grow-out and finishing and so forth. So it's a very flexible system, and it gives people the capacity to steer their breeding program to focus on either a part of the system or the whole chain to maximise the improvement in profit. In terms of our work in genomics in Australia, there's really been a couple of phases of work to date. The first phase was focused around development of prediction equations for different traits and different breeds to produce direct genomic values, which were then blended into the breed plan EBVs. And simply based on the data that we had, the research data that we had, that's to date been most effective for only Angus and Brahman. We simply did not have enough data for Hereford and some other breeds to generate useful prediction equations. Alongside that, in this, what I've called the first phase, a number of genomic tests of one form or another have been developed and made available. Horn pole is an example, breed composition, SNP parentage, and so on, all becoming available and more widely used. But more importantly, the phase or the step that we're now moving through, or the phase that we're now moving through, is to take breed plan to be complete single-step multi-trait, and that's happening as we speak, and we anticipate it being implemented in the breed plan system for all the major breeds where there are animals that have been genotyped during this year. The really important challenge around genomics, I think, is alongside having software that deals with the data properly, is to actually have the phenotypes to underpin genomic selection, to have enough data to underpin reliable breeding values. We've developed a system in Australia which we've called the Beef Information Nucleus, or BINS, to help us collect enough phenotypic data to make genomics work. And there's been two models of that to date. The first, simply built on progeny testing, so groups of bulls from a particular breed being brought together to breed progeny and measure the performance of those progeny in both the growth phase and the maternal phase, in some cases just the growth phase. But that's a fairly simple model, and it allows you to collect lots of records at relatively low marginal cost on animals that will then underpin the genomic prediction. There's also been some work, particularly in the Wagyu breed, of simply using commercial data straight from the feedlot and the processing plant and genotyping those animals, much as Donna's described a few minutes ago. That's been particularly useful for carcass traits and some of the eating quality traits that we're interested in. The big challenge around this area, I think in the long term, is going to be simply maintaining the investment in that recording cost. There's $2 to $3 million a year going into these projects at the moment. So far, usually a mixture between the breed and the government. Whether that will be able to continue, we don't really know, but there is no question you've got to have that data, and so we've got to continue to work on finding ways to fund that research. Now, I just want to give you a little bit of an overview about Herefords in Australia. This is from a geneticist's perspective. I think yesterday you would have heard a little bit about the breed from John McHugh. First of all, the breed, as I said before, has its own indexes, and this is just an example one, and this is simply a graphic that's showing you the emphasis that's put on different traits in one of the indexes used by the Hereford breed, and you can see it's been simplified down on the right-hand side there. Just to summarise that there's approximately a third of the emphasis in this particular index is going on calving ease, about a quarter on carcass traits, 30% or so on growth, and a bit on reproduction. But the full range of traits there, you can see that are contributing to profit in the value chain. Each one has been valued and they're all contributing to the index. And Hereford has several of indexes built around this sort of breeding goal. I'll come back to that in a moment. In terms of recording, there are approximately 30,000 or so Hereford animals being registered and evaluated in Australia and New Zealand per year. Something like 90% of them are in herds using breed plan. There's a big range in the recording quality, but there is also the progeny test adding data. And as you'll see, Herefords are active in the Genomics R&D. There's, just to stress that point about the variation in the amount of recording that's going on, this is data that's been added to Hereford breed plan in Australia in the last 5 years, and you can see that if we work from the left to the right, that basic pedigree and identification, there's quite large numbers, just under 250,000 animals. Once we start to getting into the actual levels of recording, Approximately a bit under half the animals are getting a weight measurement. As we get into the later weights, over here, for instance, 600-day weight or mature cow weight, much smaller numbers of animals are getting those records. In the calving ease traits, not such good recording at all, only about a quarter of animals are getting them. And so as the traits get harder and harder to record, we've got smaller and smaller numbers of animals coming through with records each year. That's quite a challenge for the breed. Hereford is not alone in that sort of pattern, but simply getting data on the growth traits is nowhere near enough. This is simply an example from the Hereford breed plan pages on the web, which I'm sure some of you will be familiar with. It's identifying leading bulls from the current evaluation, and it includes, to the right of the screen, the 4 main indexes that the Hereford breed uses, and so that information is there all the time, and people can access it and see the genetic merit of the animals in the breed. In terms of numbers of animals in the breed, there's been quite a stark pattern over the last 20 years in Australia. When breed plans started back in the mid-1980s, Hereford was a very significant contributor of new animals, new records, and you can see the blue line there is the Hereford numbers, but they've dropped back over the last 20 years quite considerably. The red line is the other British breeds, which particularly includes Angus, and so there's been quite a shift in the relative numbers there. That's a real challenge for the breed, and I know they're working very hard on it, but it's certainly a significant feature of the breed's history over the last 20 years or so. But at the same time, breeders have been using breed plan to make genetic progress with some considerable success, and I've just pulled out a small number of traits to show you the Hereford genetic trend and then the other British breeds. This is for 600-day weight, so you can see there's been improvement in growth rate in Hereford cattle. This is marbling. It's not such a good story, intramuscular fat. The other British breeds, particularly Angus, have made a lot of progress for marbling. Hereford to date have really not been focused on that trait, and in our markets that's quite a significant, important issue. We have a national essentially grading system for meat, so customers can identify eating quality when they go to the supermarket, and marbling is an important trait for that, so that's a challenge for the breed. If we look at overall index, Hereford's roughly keeping pace with the other British breeds in terms of overall genetic merit for profit, but you can see there's still some room for improvement there. Now just a few minutes on the research and development that the Hereford breed is conducting. The 2 big projects, first of all a information nucleus project which is evaluating something like 12 to 15 sires each year coming in to be progeny tested. That's quite a significant achievement for the breed. Having said that, they're not the only breed in Australia doing this sort of work, and Angus are doing this on a big scale, Brahman and Wagyu similar to Hereford. The really good thing about this project is there's the sorts of traits that farmers cannot easily record are being collected in the information nucleus project, including the eating quality traits which are having a bigger and bigger effect in our market. And so MSA is Meat Standards Australia, and so the Hereford bulls are being evaluated for a number of traits that contribute to eating quality, and the genomic predictions are going to be available to allow people to select for those as the information accumulates. In parallel to that, there's a project that the breed has innovated with where Hereford bulls are being used over Angus cattle and being compared directly with Angus sires, and that data is called the Black Baldy project. It's got links to the Hereford Information Nucleus project and similar projects in New Zealand, and so that's going to add data on F1 progeny and also allow a direct comparison with Angus cattle, and that will in turn feed into the genetic evaluation and improvement of Herefords in our country. Just to reiterate the point about genomic prediction, which Donna's already talked about, and I'm sure Dorian will as well. But basically the fundamental of it is that you've simply got to have a reference population of some form where you've got animals that are both phenotyped, they're recorded for the things that are important, and you've got their DNA. So you've got phenotypes and genotypes. They're the reference population. Once you've got that reference population in place, then people can simply take a hair sample or DNA sample on young animals and get a genetic evaluation for all the traits that have been recorded in the reference. So Hereford have got the 2 projects there that are building their reference population, and that's opening up the possibility for people to be able to evaluate young bulls simply on DNA. And that information is being fed straight into the breed plan system so that people can do the genomic testing and get breeding values back for those traits that are being recorded in the reference population. And the traits that are being incorporated is considerably expanded over what normal recording usually occurs. Herefords aren't doing all of these at the moment, but the principle is there, and they're moving in that direction. And quite a number of these traits are significantly easier for breeders to get information on once we've got genomics. And so things like fertility traits, feed efficiency, Hereford cattle are being measured for individual feed intake. That'll feed into feed efficiency genomic breeding values. Disease traits such as BRD will become increasingly important, and towards the bottom there you can see the traits that affect the consumer experience. So eating quality traits will be part of the genomic prediction. So to finish off, I just really like to stress something that I think is so overwhelmingly obvious that it's the main message of my talk. Hereford is a strong, viable, valuable breed in our country, but they need to make the best use of the best genetics anywhere in the world to really improve the profitability of Hereford genetics in Australia. And I think that's a challenge for every country. And so I think it's really important that we work towards some sort of coordinated multi-country genetic evaluation. That could simply be by data sharing, so countries essentially giving each other their data, or putting data together in some central locations and running it all together to produce EPDs and EBVs relevant to each country. That's going to include sharing genotypes as well as sharing phenotypes. Underpinning that will need to be some really strong global collaborative R&D, particularly about understanding the genetic relationships between countries, the relationships between traits in different countries, and also understanding what exactly are the breeding objectives in different countries, whether everybody's trying to breed the same sort of Hereford cattle or different ones for different countries. And I think that should lead to making more and more use, if possible, of really elite young sires so that they're getting progeny in several countries at the same time, so that all the populations are using the very best genetics from wherever they get them. Doing this sort of work will be a win-win for every country that participates in it, and I personally think that Hereford cannot afford not to do it. You simply can't afford to not use the best genetics from wherever you get it. Putting that in place, each country will need to have the results expressed in the way that they're used to that's relevant for their local country, whether it's EPDs or EBVs. For each country needs to be customised and adapted, but the most important thing is that it will allow breeders in each country to maximise the intensity of selection, to get the best genetics for use in each country from wherever it comes. The breed obviously has been a very important part of beef production in our country and can be again in the future, but I would see this sort of international genetic evaluation, sharing of information, making the best use of animals from anywhere. I think it's absolutely essential for the future of the breed in Australia. Thank you.